Hello everyone, welcome to my channel ICSE Physics, Keeping Intellectually Engaged. Today we are going to solve a couple of important numericals from exercise 3A, numerical section of your ICSE grade 10 Selena textbook. All of you may please refer the textbook and solve with me if you do not understand the concept. Let us begin. Question number 5. Let us read the numericals. Before solving a numerical, we have to understand that situation very thoroughly. A man uses a crowbar of length 1.5 meter to raise a load of 75 kilogram force by putting a sharp edge below the bar at a distance of 1 meter from his hand. Draw a diagram of arrangement showing the fulcrum, load and effort with their directions. State the kind of lever. Calculate load arm, effort arm, mechanical advantage and the last the effort needed. The first part of the question, draw a diagram of arrangement showing fulcrum, load and effort with their directions. So let us draw a diagram. A crowbar of length 1.5 meter. A crowbar of length 1.5 meter. The total length of the crowbar is 1.5 meter. It is supported at a sharp edge. Let us draw the edge, sharp edge here. This sharp edge, the supporting edge acts as a fulcrum. All of you know it. Okay. At a distance 1 meter from his hand, where this edge is supported at 1 meter from the handle, Okay. At the handle, you apply the effort to lift the load. All of you know it, and we keep the load at the other end. Let the load be here at this end. The magnitude of load is given as L is equal to 75 kilogram force. Okay. Yes. So the load, fulcrum and the effort. So the first part of our question is over. We have drawn a crowbar with the fulcrum, effort and load. Okay? Yes. Now coming to the main part of the question. State the kind of the lever. What type of the lever it is? First part. State the kind of this lever, B part. A part is over, we have drawn the diagram. You know that the fulcrum is acting between effort and the load. When the fulcrum is at the middle, I told you to remember the mnemonics FLE, F-L-E. Fulcrum at the middle belongs to class 1 lever. So of course the fulcrum is at the middle, it is clearly visible in the picture. So it is class 1 lever. Okay? Yes. C part. C1. Calculate the load arm. Load arm. What is load arm? You know that the load arm is the distance between the fulcrum and the load. So what is load arm? Load arm is equal to the distance between fulcrum and the load. The distance between effort and the fulcrum is 1 meter and the total length of the crowbar is 1.5 meter. Then what will be this distance? Of course 1.5 minus 1, this will be 0.5 meter. So load arm is equal to 0.5 meter. Okay? Yeah, okay. Next, C2. What is the effort arm? Effort arm. Effort arm is equal to the distance between fulcrum and the effort. That is, it is clearly marked here, 1 meter. All of you can do it. Effort arm 1 meter. Okay. And the third part is mechanical advantage. Mechanical advantage is equal to, you know the formula, effort arm upon load arm. Okay, right? That's equal to, what is effort arm? 1 divided by 0.5. Load arm is equal to 0.5. That is equal to 2. So it's a pure ratio, it has no unit, keep it in mind. Okay. The last part, the effort needed to lift a load of 75 kilogram force. The effort is acting here at the handle. We don't know the magnitude of this effort acting. We have to calculate it. The last part, effort. We know that effort is equal to, or mechanical advantage is equal to load upon effort. Mechanical advantage is equal to load upon effort, very simple. What we have to calculate here? Effort. Therefore, effort is equal to load upon mechanical advantage. Load is given there. What is the load? 75 kgf divided by mechanical advantage is 2. 75 divided by 2, that is equal to 37.5 kilogram force. Kilogram force is a unit of force. Load is nothing but it is a force. This is the kilogram force, is the gravitational unit of force. SI unit of force is Newton. Okay. Is it clear? Yes. Now, moving towards question number 6 of your textbook, exercise 3A, numerical section. Question number 6. Okay. Yes. Let us read the question. A pair of scissors is used to cut a piece of cloth by keeping it at a distance 8 centimeter from its rivet and applying an effort of 10 kgf by fingers at a distance 2 centimeter from the rivet. Find the mechanical advantage of scissors and the load offered by the cloth. How does the pair of scissors act as a force multiplier or as a speed multiplier? Okay, let us solve it. Question number 6. A pair of scissors is used to cut a piece of cloth. If you don't understand the problem, try to draw a figure of scissor. Let us draw a figure of scissor. A scissor. A pair of scissors is used to cut a piece of cloth by keeping it at a distance 8 centimeter from its rivet. What is rivet? Rivet is nothing but a joining point. This joining point acts as the fulcrum, that you know it. Okay. This is rivet. Rivet is nothing but it is fulcrum. A piece of cloth is kept at a distance 8 centimeter from its rivet. Keep off piece of cloth. Of course, that piece of cloth will act as the load. So, load at the blades L is equal to B, magnitude is not given. The cloth will act as the load there. Okay. At a distance 8 centimeter from the rivet. What is this distance? 8 centimeter. Okay. Yes. And applying an effort of 10 kgf. Effort is applied at the handle, that you know it. E. Effort is acting at the handle. What is the magnitude of effort? 10 kgf. By fingers at a distance of 2 centimeter from its. What is the distance from the fulcrum? This is 2 centimeter. Okay. Yes. So, diagram is complete. So, from the diagram we have to calculate the mechanical advantage of scissors and the load offered by the cloth. First, A part, A1. The mechanical advantage of the scissor. Mechanical advantage is equal to effort arm upon load arm. All of you know the formula. Okay. What is effort arm? Effort arm is the distance between fulcrum and the effort. So, effort arm is equal to, write the data here, no problem, 2 centimeter. Load arm is equal to the, what is load arm? Distance between the fulcrum and the load where you keep the cloth. The cloth serve as a load there. Load arm is equal to 8 centimeter. So substituting the value, effort arm 2 divided by 8, that is equal to 1 by 4, that is equal to 0.25, right, 0.25. So 0.25 is the mechanical advantage. Okay, yes. And second part of the question, the load offered by the cloth. So we have kept a load at its blade here. The load, we don't know the magnitude, that we have to calculate. Okay, yes. Very simple. Mechanical advantage is equal to load upon effort. What we require? Load. Therefore, load is equal to mechanical advantage into effort. That's equal to, mechanical advantage is 0.25 into effort is 10 kilogram force. 0.25 into 10, that is equal to 2.5 kilogram force. So this is the load. So we have calculated the magnitude of the load, right? Yes. Is it clear? The last part of the question, B. How does the pair of scissors act as a force multiplier or as a speed multiplier? A pair of scissors, which type of lever it is, which class of lever? I have told you we can classify the levers looking at the mechanical advantage. If the mechanical advantage is greater than 1, it acts as a force multiplier. If the mechanical advantage is less than 1, it acts as a speed multiplier. If the mechanical advantage is equal to 1, it is used to change the direction of the effort of blade. So what is the value of mechanical advantage here? We have calculated the mechanical advantage is 0.25. It is always less than 1. So we can say that since mechanical advantage is less than 1, it acts as a, the scissor act as a speed multiplier. Speed multiplier. Okay. So that part is. Now let us solve question number 7. Question number 7. Let us try to read and understand the problem. A 4 meter long rod of negligible weight is supported at a point 125 centimeter from its one end, and a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. If a weight W is placed at a distance 250 centimeter from the support on the longer arm, find W. If a weight of 5 kgf is kept to balance the rod, find its position. And the last part, to which class of lever does it belong? You can see this question has got 3 parts. Obviously, this question carries 3 marks. Let us solve. A 4 meter long rod, just draw the diagram. Whenever you get a numerical, put all the data in the form of a diagram. 4 meter long. What is the length of the rod? 4 meter. That is equal to 400 centimeter. That is the total length of the lever. Okay. A 4 meter long rod is negligible weight is supported at a point 125 centimeter from its one end. Where it is supported? At the fulcrum. What is the distance? 125 centimeter. 125 centimeter from one end. Okay. And a load of 18 kilogram force is suspended at a point 60 centimeter from the support on the shorter arm. Now the fulcrum acts at the middle. Now the rod is divided into 2 arms. 125 centimeter. What is the remaining? It is 275 centimeter. 275 plus 125, it is total 400 centimeter. Right? Okay. So this is the shorter arm whose length is 125 centimeter, and the longer arm is 275 centimeter. Okay. So the fulcrum divides the rod into two arms. Okay. A load of 18 kilogram force is suspended at a point 60 centimeter from the support on the shorter arm. 60 centimeter from the support. So where it is? Here, let it be here, 60 centimeter. A load of 18 kilogram force. What is the load? Load of 18 kilogram force is suspended at a point 60 centimeter from the support. Read the questions very thoroughly. 60 centimeter. 60 centimeter from the support. Okay? Yes. On the shorter arm. So the data is given in the question. We have put it in the form of a diagram. Okay? Yes. Now the question number A. If a weight W is placed at a distance 250 centimeter from the support on the longer arm, find W. That a weight of W is supported on the longer arm, where it will be on the longer arm. The longer arm is of 275 centimeter. Let the weight be here. Let the weight supported here. Okay. Weight W. We don't know the magnitude. At a distance 250 centimeter. How much? From, what is the distance? 250 centimeter. Okay. From the support. Remember that, from the support. Read the questions clearly. Find W. This W we have to calculate. Now we know that the whole arrangement acts like a simple lever. We have to calculate W. Of course, we have to apply the principle of moments. So W, the moment due to W, let it, you know that it is acting clockwise, CWM, and moment due to a load of 18 kilogram force with respect to the fulcrum F. It will be anti-clockwise moment. Okay. So we know that when the lever is in equilibrium, clockwise moment is equal to anti-clockwise moment, according to the principle of moments. What is clockwise moment? Force into distance. What is the force here? W. We don't know the magnitude of it, which you have to calculate. W into, what is the distance? 250 is equal to anti-clockwise moment. Moment due to the load. Load into the distance. That is 18 into, what is the distance? 60. We want to calculate W. W is equal to 18 into 60 divided by 250. Okay. Yes. Cancels. 18 6 are 108 divided by 25. 108 divided by 25 is equal to 4.32 kilogram force. 4.32 kilogram force. So that is the value of unknown weight. Clear? So applying principle of moments, we have calculated the value of unknown weight which is supported on the longer arm. Okay? Yes. Coming to B part. If a weight of 5 kilogram force is kept to balance the rod, find its position. Okay. Now, fulcrum. Okay. It's already acting there. From the fulcrum already there is a load of 18 kgf at a distance 60 centimeter from the fulcrum. Now, according to the question, let a weight of 5 kgf, let a weight of 5 kgf, load is equal to 5 kgf, kept to balance the rod, find its position on the other end. Let the weight 5 kgf be at a distance D. We don't know the distance, that you have to calculate. D from the fulcrum. Okay, we have to calculate this distance. What is this distance? Okay, again you can see it is just like a simple lever. You have to apply the principle of moments. This will serve as clockwise moment, and this will serve as anti-clockwise moment, ACW. So when the lever is in equilibrium, clockwise moment is equal to anti-clockwise moment. Okay? Yes. So what is clockwise moment? Clockwise moment is equal to force into distance. Force 5 into, what is the distance? We don't know distance. Let it be D is equal to clockwise moment. What is the force acting here? 18 into, what is the distance? 60. Therefore D is equal to 18 into 60 divided by 5. 12 5s are 16. 12 18 is equal to 216 centimeter. That is equal to 2.16 meter. Is it clear? So applying the principle of moments, we have calculated all these values. Remember that when the lever is in equilibrium, clockwise moment is equal to anti-clockwise moment. Okay. Thank you for watching. Now moving on to the last part of the question, C part. To which class of lever does it belong? So you can see that, look at the picture. The fulcrum is at the middle between load and effort. The fulcrum is acting at the middle, right? When the fulcrum is acting at the middle, of course, this lever belongs to the class 1. So therefore, class 1 lever. Okay, when fulcrum is at the middle, FLE, flee, fulcrum at the middle. Just remember the mnemonic. Fulcrum at the middle, first class lever. Load at the middle, second class lever. And effort at the middle, third class lever. And in our case, fulcrum is acting at the middle, so it belongs to class 1 lever. I hope all of you understood. All that for today. Thanks for watching.